Hey everyone. So from today we are starting our Docker series, and in a week we will cover Docker, Docker file, compose, network, volume, and some troubleshooting and some other cool things. And the starting of this series will be of course from understanding the difference between bare metal virtualization and containerization, right? Do not think like now that the containerization is modern technology we have for cloud, these two are like abolished or they are still there. These three work together to give a fully functional efficient um, infrastructure that we can use and run our demand or applications or anything. Okay, they all work together and they are not like a uh, three tools and you have to choose like which one is the best. They all work together, they have their importance in the society of IT. Okay, so now yeah, let's start. So the very first option we have is bare metal. Okay, so bare metal is simply like this. Your PC. Okay, how's your PC? You have your hardware. Okay, you have your hardware, you own your hardware, your RAM, CPU, input output, storage, everything. It's all in the hardware. Okay, and then you have your host operating system. It can be Windows, it can be Linux, and that operating system has full control of your hardware, right? Your Windows have all the 16 gigs of your memory, all the CPU cores. Your Windows can control all of the resources. It can see, it can work on that, and it can basically utilize all of that. And then on top of your host operating system, you will have your basically workload, your Valorant, your CSGO applications, everything. It will be on the host OS. So now bare metal is like in early days of servers, we had this bare metal in production. Okay, where there would be one server rack with let's say 64 gigs of RAM and 64 CPU cores. That's a lot, but yeah, let's say there was this one server which had all this. Okay, now on this server only one application would be running. Like you have this server, on this you would install an operating system like Linux, and then you would install your application. Now this was a very expensive thing, right? You have your own server, it cost a lot, and in previous time things were very expensive. Okay, so it was very expensive. Apart from being expensive, it was very inefficient. You are not using 64 GB of RAM all the time. Okay, sometime you would be idling at what, like let's say 16 gigs or 4 gigs and only utilizing 2 CPU cores. Okay, it could vary upon the demand you have, the peak hours, the midnight normal rush, all that thing. Okay, so you are not efficiently utilizing your whole server rack, but you have to keep your server on to process even one function, or be it like 1 lakh a calls. You have to serve all those requests, so you cannot turn it off, so you have to keep it on. So everyone had their own dedicated server. The only one client application is running here, and yeah, it was very inefficient and expensive. But there is one good thing about this is isolation. Now what isolation mean is like in a, let's say I was a 90s server company, I would provide or like it was on premise, so I have let's say 5 server rack. These are 5 server. Okay, they all have their own specifications and in resources. They all have their own application that they are running. Now isolation is like how much these can interfere with each other. Okay, so these are all hardware level separated, right? This app is only using his own host hardware, right? It is not asking anything from this or this or this or any of these. They all are very independent. They are very, uh, you can say, disconnected from each other in terms of sharing the resources, right? No one is sharing anything. They all are using their own. So, just in case, let's say if this has utilized 100% of its resources, this application is like very slow or crashing now because there is no free resource, it will not bother these four. They all are safe. So this is called actually noisy neighbor situation, where when there are a group of things, how much one is bothering other. Okay, so this one is only bothering itself. Okay, it is not bothering these four. Okay, so this was a very good thing about bare metal. Again, it comes with the cost of very expensive and inefficient and not very scalable and all, but this was the good part. Second good part was security. Now in security, if this, okay, this is already dead. Okay, now let's say this had a very you can say a PHP version which is very exploitable. There is a CV in that PHP. This application is using that, and now this application is hacked. Someone has the access of this application. Now this is hacked, so the hacker cannot hack these three. Okay, there is a caveat. If they can jump into the main network and access all these, that is a different scenario. But on the surface level, this system is compromised, then these three are again safe because they are hardware separated. There is no connection between them usually. Okay, so if this is hacked, this system is out of let's say service, these three are still safe. So it was very secure. There was the isolation was very very good. So in modern days, okay, no one is using like directly giving you a bare metal. Typically, okay, typically we are using virtualized systems. You do get a isolated bare metal system which is called tenancy tenancy in AWS. Okay, so if you go in AWS and if you try to spin some EC2, just search metal dot metal. So like we have T2 dot micro, and also there will be something like I3 dot metal. Okay, I'm forgetting this, but yeah, just go launch a EC2 and for T2 dot micro, instead of that, search for the metal one. They would be dedicated server rack. Okay, you will have like 64 gigs of RAM and 32 CPUs and all that. So you will be the owner of all that hardware. Like, of course, you are renting it out. You do not own, but you have the full control of that. There is no other client running on that rack. Okay, so if let's say there is some compliance, okay, policies, yeah, if there is some special requirement, some policies that okay, what we are running is very sensitive, very confidential, and we want it on a proper dedicated something, we can go for on premise. Of course, this is like the most secure in this situation. But yeah, in cloud we would take like the tenancy, we will change it from shared to personal, you can say, and you can just rent the whole rack. So in normal uh, day, your PC, your laptop, this is all bare metal. Okay, like in case of my PC, you can see like I am running Arch Linux, basically Cache OS. So this Linux has entire access to my CPU, all the power of my GPU, all the RAM, all the storage. It can access all of that. It can use all of that. Okay, so that was bare metal. Now let's see virtualization. So in virtualization, as you can see, we have our hardware, of course, and then we have hypervisor, and these are our virtual machines. Okay, app1, app2, app3, these are all like virtual machine 1, virtual machine 2, virtual machine 3. So hardware is clear to you, no big deal. Now what is hypervisor? So hypervisor is like a code, okay, is a kind of a very specialized operating system whose whole task is to virtualize hardware. What this mean? So in the previous case of bare metal, okay, we were this operating system had control of this whole hardware, okay, all the 64 gigs of RAM, all the CPU cores, it is given to this operating system. It has all of it. But in virtualization, it's not like that. We virtualize it, okay. So what hypervisor will do is, let's say this hardware, it has 64 GB of RAM and again 64 CPU cores and let's say 100 gigs of storage. So hypervisors will virtualize it, okay, according to the virtual machine configurations. So let's say I am spinning a VM. Okay, let's say this is virtual box one. It is running Linux, and we define like, okay, you will be using 4 GB of RAM and two CPU core. So hypervisor will take out that much from the main hardware. It will virtualize it and it will give this to this VM. So now this VM, this VM, it will not see all of this. It will, it has no idea like the server has 64 gigs of RAM. All this can know is that all you have is 2 GB of, two CPU cores and 4 GB RAM. Why? Because this whole thing is abstracted. This is all like the low level thing. We have our hypervisor and it is virtualizing, it is controlling all the hardware resources that is going to the virtual machines. So now this two CPU core and 4 GB is the reality of this virtual machine. It can only see this. it it is now in this delusion that it has like the whole access of hardware, but the only hardware access it has is only these CPU cores and these RAM. Why? Because hypervisor is controlling it, okay. And now let's say I am spinning another VM with some again resource allocations. This VM will only see that much, okay. Whatever x by z we have allocated, it will only see that much. It will think like, okay, this server has only this much and I am owning all of it. This virtual machine will think the same. These two are not aware of about each other, like, oh, I have a neighbor also. No, they think like, okay, I am the only one that is running on this server. And these two are controlled by whom? Hypervisor, okay. It is just abstracting all of these resources, virtually separating it and allocating it to virtual machines. And then again, in virtual machine, we will have our operating system, we will have our binaries and our application. Operating system, kernel, okay. Binary libraries is like, okay, you are running a Node.js application. So you have Node.js installed, any libraries that you are using, any language or something, it is installed on that. And then you will have your main application. So this was like after the bare metal thing, when we got this virtualization, we were using basically virtualization in production. One more thing, normally you would see a host OS in many diagrams. You will see a host OS at this level. So that is actually due to we have actually uh, pen two type of hypervisor, type 1, type 2. So type 1 hypervisors are actually the hypervisor that can directly control the hardware, okay. They do not need any underlying extra operating system to control your system resources. Sorry about that. And type 2 is like, okay, they will rely on operating system. So I am sure you guys would have seen something like this. Wait, F11. So you all would have seen this virtual box, okay? The one that you would normally install on your Windows and run your Linux thing, or even VMware, okay? So these normal ones that we install, these are actually type 2 operating system, okay? I would install this on a already running system, okay? And yeah, by the way, don't go this on URL. This is my own home lab setup. So if you want this application, it's actually Excalidraw, and you can go to this website, okay, and you can just do all that. But this is like the self-hosted in my home, so yeah, it's private actually. Okay, so these type 2 hypervisor, they need what? A host operating system, like Windows or Linux. It needs a underlying operating system, but in type 1 they can directly control. So like there are two very popular one, that is VMware ESXi, and from Microsoft it is Hyper V. These are very famous type 1 hypervisors. And if you want to test something, like if you want to try out a hypervisor on a machine that you might have on home, you can use this actually, Proxmox. You can use this. Just take a old laptop and install this. And when you boot, you will have an operating system, but it will be more towards managing everything and not running your workload, like directly running your node application or website. It will just give you a platform that can run virtual machines and containers. Okay, so now if we talk about the advantages we would have, first of all, utilization. Now, on a single server rack, we can have a hypervisor instead of operating system, and now we can have multiple application, okay, running on same server, and they all are unaware of each other. They all are isolated at hardware level. So this does not know about this application, these two are not aware about, no one is aware about anyone, okay? They cannot, in a normal secure situation, they cannot disturb each other. They cannot uh, the noisy neighbor situation, there is no noisy neighbor situation in this. If this app has, let's say, maxed out its resources, this app will simply crash. But the thing is, this app does not have the whole hardware, okay? It has just a portion of it, okay? So these two will again be safely running. Now there is again a caveat, that is, if there is some security, some attack, some virus that can get out of this virtual machine, it can like just escape that and enter at your hypervisor level, then things can go very bad, okay? It can just basically f up your whole server. But in normal case, it is not, you of course, production level things, they are taking care of securities. But yeah, that is like a overall caveat that is there. Now, there is again very less or very almost no kind of noisy neighbor situation here. If again, let's say this thing got hacked, this server is dead, okay? This client is in trouble, but this app, it will run again very fine. Second thing is isolation. There is hardware level isolation. So it is again a good thing, okay? No one is interfering with each other, no one is aware about each other existence. So what is there? The advantage is we can now utilize our most of the server. Not every application would need the whole 64 gigs of RAM or all the CPU cores. So we can divide them, right? We can give let's say 8 GB to one of our customer, and the let's say 10 GB to this, 8 to this, and 20 to this, okay? They all would have their own resources according to the plan they would have, right? Now the thing is, a virtualization is efficient in utilizing resources, utilizing be it cloud resource or servers, basically servers, machines. They are efficient in utilizing these, but they are not efficient when it comes to running the cloud workload, okay, or running the workload basically. Why is that? uh, the era, it's the era of cloud, okay, and we want to scale as quickly as possible, and also scale up, scale down. Also, we want to use things efficiently, right? Issue with that is you have a virtual machine. It is 3, let's say 8 gigs of size, your virtual machine. Now if you want to replicate your application, let's say you have a peak hour coming and you want, instead of one server, one instance of your application, you want 10 instance of your application. So you will basically create a snapshot, okay. What snapshot? It's actually like a backup file of your virtual machine, which you can use to replicate. So you have your snapshot. This is the snapshot. Now you want to have 10 instance of your application. You would have to first actually create a snapshot. Then second, you would have to, actually install that snapshot, and then you would have to start all those 10 VM machine, and it is gonna take a lot of time because these are again a very, they are again big files, they are the whole operating system. Whereas in containers you are not literally booting up a operating system, but in virtualization you are starting from scratch. You have the whole operating system, the whole kernel, libraries, system in it. uh, you are doing everything from scratch, so it will take a lot of time. The other thing was compatibility, or you can say portability. Yeah, that would suit better. How portable your application is. Now let's say there are two server rack, and in this server rack I am using VMware ESXi. In this I am using Hyper-V. Two different hypervisors are running on this application. So if I take a snapshot from this application, I will get a snapshot file, something like, let's say, xyz dot avhd. This is like the disk image, okay. And now you would have to install this disk image to other system, like ISO files of Windows or Linux. If you want to replicate that, uh, if you want that operating system, you have to install that ISO file and then just set up that ISO and you will get your operating system, right? So it is just like that. It is a ISO, but in a different format. Okay, these companies would have their own. Because Hyper-V, their format is VMSN. So let's say XYZ dot VMSN. These are not compatible with each other. Okay, so if you want to run this snapshot on a on another hypervisor, another server, either you have VMware ESXi hypervisor on that server also, and if you do not have, then you would have to, like, refactor your um, disk image and make it compatible with Hyper-V by converting this into this format, and it is a very hard, and I mean, have never done this, okay, but as per my research, people who mentioned this as pain in the ass process. So this was there, okay. Things are not very portable, okay. You will have to refactor things for different architecture and all, and then only you would be able to run it. But again, it is not as fast as containers. It is not very quickly scalable, quickly scale up or scale down. It is not gonna start in 1 second, or it will take minutes to start and stop, right? So virtualization is still used, okay. It's not like this is absolute. So if you take your AWS, normally in how it works is, they have their own hardware. On top of that, they have their hypervisor, VISOR, and on top of that, we clients, when we run a EC2 or something, they will give us this EC2, okay, and then we will run our workload on that. So it's not like virtualization is old thing, okay, it is still being used now. So portability was not that great, scalability was not that great, but yeah, isolation was good, right? You had good isolation, noisy neighbor situation was also good. Nobody is disturbing each other, cause again they are very unaware of other existence. They think they are the only one that is there on the server, but they are not, cause this is all just a illusion given to them by our hypervisor. So yeah, if you want to, test a hypervisor, I would suggest you play with Proxmox. Proxmox. You can run LXC containers and ISOs. I personally am not using any Proxmox. Proxmox in my home lab. I'm simply just running pure Debian there. So yeah, let's get to containerization now. So we have our hardware. Okay. Then we have our host operating system. Now again there is this thing. There will be some hypervisor if you are running it on AWS or something. But if you are running, let's say, on your laptop, then it would be simply like this. But yeah, it is just, the underlying differences could be different. Now after this, we have our container runtime or container engine. Now this runtime can be, Docker, container D, PAINER, container D, Podman, another good option. So it can be any of these, this runtime. Now this is using Linux kernel, okay. These are actually sharing the resources, or basically utilizing the host operating system functionalities to run containers, okay. Uh, they There is no hardware level separation, okay. These are not virtual machines, these are containers. They do not have their own operating system, their own kernel, okay. Container runtime, let's say Docker is using our host operating system for that. So see, Linux kernel is very important in this case. KERNL. So what happens is, in Linux kernel we have some features like C group and namespace, and there's also UFS, union file system. So Docker utilizes these three from our host operating system, like my operating system. Linux would use these functionalities to run a container in an isolated environment. So any application needs few things, okay, to run. One is their your, let's say, source code, libraries. These are packaged in a container, right? Now Docker will create separate process IDs, separate mount system. Like these are again features of Linux kernel, and uh, there would be C groups, there is network. So all these things, there are in total 8 namespaces in Linux, and 6 are by default used by Docker. Other is user namespace. This is not like you can enable this option in Docker to use this namespace. And there is this new namespace time, which is as of now is not used or supported by container. In later it will be, but for now think like we only have these 6, okay. So these 4 are one of them. So this will give each of these containers their own process ID, their own file system, their own network interfaces, and then these containers would spin up. So in previous case where we had hypervisor that was virtualizing the everything on hardware level, and then we would start a whole operating system. Containers do not have that problem. Okay, they do not have to initialize a operating system. There already is operating system running, right? So like, uh, as of now I have nothing here. Wait, let me just get into my server, and now if I run docker ps, there are some docker containers running. Now, they do not have their own operating system. Okay, they all are running on the Debian that I'm running on my server as my host operating system. So when I spin a container, it is not starting a whole, operating system. It is simply starting the application. Okay, but the thing is, we need to have isolation. Okay, we need to have isolation among these containers, so we do not get this noisy neighbor situation. Or if you know let's say there are these three containers. So first, we do not want this container to use up its all of its resources, and now it is taking resources from this container and slowing down this container, right? Or if this container is hacked, I do not want this container to again the virus to get out of this container, get into this container, and then hack this container, and then hack this container. It will be literally disastrous, right? So of course, in virtualization, it is very hard, but in containers, it is less secure in terms of that. Okay, the isolation is not happening on hardware level, but simply kernel level. Okay, all these containers are sharing the same kernel. Okay, all these containers are utilizing the same kernel, but since this is Linux kernel we are talking about, even Windows have their own work around. Like, I do not know their terminology, but yeah, in Linux we would have these C groups. C group basically determine how much resources that we are about to give to any container. So like, if container one can have 200 MB of RAM, then it is the C group duty to make sure this container can only have 200 MB of RAM from the whole host system, and it cannot go more than that. There are namespaces that make sure the isolation is there, so everything has their own process ID. So if this C1 has, let's say, process ID of 417, C2 has 418, C3 has 419. Container 1 can only see this, container 2 can only see this, container 3 can only see this. They are not aware about each other. Okay, there is way to make sure they are aware about each other is when these two containers are on same process ID. If they are on the same process ID, they can see about each other. Okay, it is a cool thing which can be done through the command ns-enter. It is a bit I would say advanced thing. Maybe someday I will show this. So this separation is happening by using the features of Linux kernel. Okay, be it PID, MNT, um, network, net. So when a container is start, Linux kernel will attach, give these container their own ether internet interfaces. It will give their own file system. So like, from your host operating system, a tiny bit will be given to this container. Now for this container, it is again in the delusion that I have the whole server or the whole operating system resources, but it has just a fraction of it. Okay, it does not contain everything, control everything. But again, for the container POV, it owns everything. This network interface, this will give this network interface of its own to work, process ID of its own to work. This will basically help to isolate the container and make sure noisy neighbor problem does not occur. And for security also, you do not want due to one container other containers get affected or hacked. But the main issue, not a issue but the working principle of containers is that yeah, 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 is they are not doing this on hardware level. They are doing all of this in the operating system level, right? This is host, uh, operating system, okay, and then this is kernel. They are using this kernel to give that delusion to these containers. So this is less secure compared to virtual machines. Surely this is less secure, but these are very fast to start. Like literally 1 second, in 1 second you can have your nginx up and running, whereas in virtual machine you would have to start your operating system, your init system, your kernel, and then nginx service, and then you will have your application, so it will take a lot of time. But containers, they are instant, okay, because they do not have to boot a operating system. It is already up and running, okay. So startup time is very fast. They are very portable. How? We have a Docker file, right? Kerfile. So on one machine, if I create a Docker file to package a application, and then I give it to another application, another server, S1, S2, as long as the architecture is same, because we have built, let's say Linux is here. Now it doesn't matter what kind of hypervisor you are running, what kind of Linux flavor you are running, as long as they have the same architecture. This Docker file will contain everything to how to set up the libraries, any additional packages that you need, all the source code. It's all here, or even the image. Okay, the image that we will create from this. So now we just have to ship this image. We just have to ship this image here, okay, here or anywhere we want to run. As long as the architecture is same, this image can run anywhere. And again, this image is very small, okay, in mbs. This image is in mb, so it is very fast to set up, and very fast to start, and highly portable. So this is like the main advantage we have in containers. It is highly scalable. You can run from one container to 1000 container in very less time compared to virtual machine. You can just kill them anytime you want, and then we have our Kubernetes to control and manage all of these containers however we want, which is a bit of pain in virtualization. To manage multiple virtual machines, you have to not only manage the application but also make sure the underlying operating system is safe and secure and up to date with patches for all of the application, whereas you just have one host operating system to manage. As long as your host operating system is good and you are following your practices to create safer docker files, we are almost good to go. So yeah, I guess that is all. This sums up our whole containerization, virtualization, and bare metal thing. So the thing is, bare metal, like if we take a overall summary, virtualization and containerization. So security, we have top notch security here it's not that great, okay. Like this is, again, it is secure, you can secure it, but it will not be that secure compared to these. Portable, nah, almost. This is like the best portable situation you can have. Scalability, nope, almost top notch. It's kind of this in a simple layman's perspective. Scalability matters a lot. Okay, so yeah, I guess that is all. If in the next video we will cover Docker network, we will see like these host, bridge, Mac VLAN, how what are all these, like first a bit of theory, explaining like how these works, and then we will simply do the practical of creating these networks and utilizing these network.